Hi, welcome back. Welcome to An Academy. An Academy is the India's largest online learning platform. I'm welcoming you all to the An Academy platform. About myself, I have total 16 years of teaching experience. So far, I mentored 60,000 plus students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada in VLSA domain. First, we check how to get the An Academy learning app. Just go to Play Store, there type An Academy. Now you get the An Academy learning app like this with this symbol. This is the emblem of An Academy. Now just click on this install button. It will install the An Academy learning app in your device. Once you open this An Academy app, there you get what are the different courses available and educators who are going to teach each and every subject in that respective course. You get that information. So here are the few of the top educators. See, he is the IIT topper. He is the All India rank twice in GATE electrical engineering. Okay, and he is the gold medal in IIT Indore. He is the ex IAS officer, All India rank 4. Okay, so like that. Who are the top educators from India here? Those faculty are available here, and here are few of the educators. Now I'm happy to say recently we launched two batches, one batch for GATE 2022, other batch for GATE 2023 for electrical engineering, electronics and communication engineering, civil engineering, mechanical engineering, and one batch for chemical engineering. Now for electrical department GATE 2023 there is a batch called Varvi batch. So here are the top educators handling these subjects in this batch. This batch was started from 18th of January. So during subscription, don't forget to use my code VROUT10 to get the 10% of discount. Next, Spark batch. This is for GATE 2022 for EC students. It was also started from 18th of January. And don't forget to use my code VROUT10 during subscription. And again, Varvi batch for EC students. Now this time, this is for GATE 2023. Don't forget to use my code VROUT10 during subscription. This was also started from 18th of January. Okay, again Spark batch for triple students for GATE 2022. It was also started from 18th of January. Okay, don't forget to use my code during subscription VROUT10 to get 10% discount. Now we go to civil engineering side. Now for civil engineering also new batches were started. Now these batches were started from 25th of January. Okay, there is a evolve batch for GATE 2022 and here are the few of the top educators handling the civil engineering subjects. And here Ascend batch for GATE 2023 for same civil engineering department, and this batch also started from 25th of January. Now there is a evolve batch for chemical engineering GATE 2022. So this batch also started from 25th January. The important thing here is it is outside it is very difficult to get the chemical engineering coaching training for GATE students. Okay, so please use this opportunity, and during subscription please use my code VROUT10 to get 10% discount. Okay, so even if your friends are there in chemical engineering, please inform this one to them. So outside it is very difficult to get the classes of chemical engineering. Okay, give this valuable information to your friends. Next, for mechanical engineering, there is a GATE Evolve batch for GATE 2022. It was also started from 25th of January. Okay, during subscription, don't forget to use my code VRAW10 to get 10% discount. And the next one is mechanical engineering itself. This is for GATE 2023. Now this time, this is SN batch. Okay, this batch was started from 25th January. Okay, so don't forget to use my code VRAW10 during subscription to get 10% discount. VRAW10. Okay, so my dear students, basically you are belongs to either electrical or EC students. Please inform your friends who are mechanical, civil, chemical students are available. Please inform this one to them. Okay, because at outside situation is not that much easy. So due to this pandemic, everywhere learning process was stopped more or less. In some countries, this academic year 2021 is there is no academic year, zero academic year. They announced already in some countries. Okay, so whatever the thing is happened at outside, our learning process should continue. It cannot stop. In that motive, we started this one. Okay, and to provide a best quality information to the students. Okay, we started this. Please give this valuable information to your friends. And here, these are the different courses handling by overview in an academy: mechanical, electrical, ECE, CS and IT, civil engineering, production and industrial, instrumentation engineering, and chemical engineering. These are the different engineering departments. Okay, we are providing training for those students. And here two subscriptions are available. One is the plus subscription. This is the basic plan, and the second one is the iconic plan. Okay, this is the next level of the plus subscription. In both the subscriptions, your classes are going to be taken by the India's best educators, and there are interactive live classes, and there are structured courses and PDFs are available. Okay, well structured course and PDFs are provided. They will provide, and live tests are available and quizzes they are going to conduct. Now, the advantage from this is, once you've written a test or a quiz examination, that respective faculty is going to analyze your paper from top to bottom. They will prepare a note that where you are strong, in which concepts you are strong, and in which concepts you need to become a strong. They will prepare that, and based on that, they will prepare a study planner to you, especially you, individual students, and they will provide that study planner to you, and respective study material also they will provide to you. Okay, and the concepts what you want, they will explain those concepts also. So that means here more or less face-to-face interactive personal coaching is going to be taken care. Okay, but if you are joining it outside, what happens? Nearly you are also going to be one of the member in a class of 50 or 100 or 150 students. Okay, during a lunch break, okay, or a tea break, okay, it is possible to interact with a faculty of hardly 5 minutes or more than 5 minutes, two more minutes more, hardly 10 minutes, not more than that. Okay, so but here personally you can interact faculty. That personal coaching is available here, and no need to move anywhere from your home. So that means you are at a secure place. Okay, at the same time, if you once observe the cost of the courses, there are two types of subscriptions: plus subscription and iconic subscription. For plus subscriptions are available for 1 month, 3 months, 6 months, 12 months, 18 months and 24 months. Okay, and these subscriptions, by using my code VRAW10 during subscription, you get 10% discount. Okay, for example, if you observe the 1 year subscription, here is 30,250. By using my code VRAW10, you get 10% discount, that is at 27,225. The beauty here is you have EMI option also available here. EMI option also available here. Okay. Now, if you compare this one with the regular expenditure, that means to attend the classes weekends or during public holidays, okay, you need to travel from your home to the classroom. Okay, and just calculate that, and at the same time, once you are coming out of your home, you need to take a lunch, breakfast, okay, some snacks with friends, like that. Okay, if you count all these things and calculate all those things, the cost of that one for a complete year is 20,000 plus. Okay, by adding a little bit amount, 7,000 plus to this 7,000, okay, you can get the complete course from your home itself. My dear friends, please check this 20,000 is your expenditure, additional expenditure, like your transport, your food, all those things. Okay, here I did not included the payment what you are going to paying the fee in the form of a fee to the institute. I'm not telling about that. Okay, only transport, external expenditure, extra expenditure with a little bit amount. Okay, just by spending that amount itself, you can stay securely at your home. Okay, and you get maximum benefits. Next, iconic plan. If you check the iconic plan, in iconic plan, personal care is more important here. Now, here two subscriptions, 1 year subscription and 2 year subscriptions. For 1 year subscriptions, it is 50,250 rupees, and for 2 year subscription, it is 74,000 rupees. Okay, now for 12 month subscription, if you get 10% discount by using my code VRAW10. Okay, so here it is, by after 10% discount, it is 45,225 rupees, and for 2 years it is 74,000. After availing 10% discount, it is 66,600. Okay, don't waste time. Okay, enroll as early as possible and get the maximum benefit. Okay, get success in your career. Now I am moving to topic. Last class we completed the Hall effect. In Hall effect, we derived an equation for Hall voltage. The equation for Hall voltage, what we derived is, in z direction, whatever the magnetic field we applied into current in a movement of current in x-axis, x direction Ix, by volume charge density rho v into width W, width of that specimen W. This is the equation for VH we derived. This is the one of the equation I am going to using to solve the problems. And one more is RH. Okay, the magnitude of RH is simply 1 by N into Q. For N-type semiconductor, it is 1 by mod Nd into Q, and for P-type semiconductor, it is 1 by Na into Q. Okay, and for intrinsic semiconductor, this is this much, mu P minus mu N by Q into E into Ni into mu N plus mu P. This is the equation for Hall coefficient. Okay, now these are the equations we are going to be using to solving problems on this. Okay, now first, before going to that, we check the applications. What are the applications of Hall effect? The first and foremost application is to find the given semiconductor is either N-type or P-type. Based on the polarity of the Hall voltage, you can represent the given material is either N-type or P-type. Hall voltage is positive for p-type semiconductor and it is negative for n-type semiconductor. Okay, and you can also measure the carrier concentration which is present inside from this. From Hall effect, you can measure the Hall coefficient you calculate from Hall effect. Now, by substituting that Hall coefficient of that material here, you can get the amount of charge carrier present in that. And once you know the RH value, from the knowledge of that, you can get the conductivity, and one can also measure the mobility of the charge carriers from that. Okay, nowadays, Hall transducers also available. Hall coefficient based on Hall effect, transducers they are going to be designing. That means sensors. Okay, so these are the few applications of the Hall effect. Now I am moving to a problem. See, the majority carriers in an n-type semiconductor. N-type semiconductor. So this is n-type semiconductor, sir. Have an average drift velocity V. Drift velocity Vd we mentioned, but here they given it as V. Drift velocity V. Drift velocity is V. In a direction perpendicular to uniform magnetic field B. An electric field is induced due to Hall effect acts in the direction. So now they are asking, whatever the electric field induced, what is the direction of that electric field? Okay. Now the direction of that electric field is Q into V bar cross B bar. This is the actual equation. Okay, this is the force due to magnetic field. Already we've written this one. Okay, force due to magnetic field. Okay, now force due to magnetic field. Now they are saying this is n-type semiconductor. So for n-type semiconductor, Q is negative. Now I am writing that one as minus Q into V bar cross B bar. Now we can write this is Q into B bar cross V bar. Now the direction of magnetic field is Q is constant. Now it is B bar cross V bar. So this is the option B. Okay. Just I applied the basic magnetic field, and after that they given it as n-type semiconductor. For n-type semiconductor, Q is negative. Just I applied that one, not more than that. Okay. I am moving to next problem. See this. The Hall constant in a p-type silicon bar is given by 5 into 10 power 3 centimeter cube per coulomb. So RHP, because it is they given clearly it is a p-type semiconductor. RHP is 5 into 10 power 3 per centimeter cube per coulomb. That is the RHP. The whole concentration in bar is per centimeter cube. What is the whole concentration? Whole concentration is how much? Clearly they mentioned it is p-type semiconductor. So for p-type semiconductor, we can write RHP or RH is 1 by P into Q. P is the whole concentration. Now from this, whole concentration P equals to 1 by RHP into Q. So now P can be written as 1 by RHP is 5 into 10 power 3 into Q is 1.6 into 10 power minus 19 coulomb. 10 power minus 19 coulomb. Okay. Now, just simplify this. So, it is 5 into 1.6. It is 1 by 8 total. 1 by 8 into 10 power 16. Okay. So 1 by 8 is let us take 10 this side. So 10 by 8 it is a 1.25. 1.25 into 10 power 15 per centimeter cube. So P value is 1.25 into 10 power 15 per centimeter cube. This is the whole concentration. So option is this one. Option is B. Okay. Now just a minute. Yeah. Okay, sir. So like this you can solve the problem. Next, I'm moving to next problem. See here, a silicon sample is doped with 10 power 16 phosphorus atoms per centimeter cube. That means they given Nd to you. Nd value is 10 power 16 per centimeter cube. Find the Hall voltage in the sample with D equals to 500 micrometer distance between bottom and top surfaces. D is 500 micrometer. Then what is the VH value, Hall voltage? And the given area is 2.5 into 10 power minus 3 centimeter square. Area is 2.5 into 10 power minus 3 centimeter square. And the given current is 1 milliamp. Current is 1 milliamp. And magnetic field B is 10 power minus 4. 10 power minus 4 Weber per centimeter square. Sir, sometimes they will give B value in terms of Tesla. Tesla is nothing but a Weber per meter square. Weber per meter square. Okay. If all the parameters are given in centimeters, you need to convert that one in terms of centimeter. Don't forget that. Okay. This is the given data. This is the given data. Now, in this, we need to measure VH value. So, this is our diagram. This is the N-type silicon. Okay, now let us take y-axis, x-axis and z-axis. I am assuming B is applied in Z axis, current is in X axis, okay, and this is the top surface and this is the bottom surface. The separation between top surface and bottom surface is D, clearly they mention, and this is the cross sectional area A. So that means this is the D and this is, let us take width W. So this is a D because already you mentioned this one here, thickness D. So our separation between top surface and bottom surface. Okay. We have an equation for VH, that VH is BZ into IX by rho V into W. So in this problem, they given BZ, what we are taking is B. They given it as 10 power minus 4 Weber per centimeter square. Next Ix, they given, we are taking it as I is 1 milliamp, and after that rho V. See, rho V is nothing but a N into Q. N is nothing but a ND. We know that amount of doping into Q. So it is 10 power 16 into 1.6 into 10 power minus 19. Its value is 1.6 into 10 power minus 3. That is rho V value. Next W, width. Now they given only D value to you and at the same time they provided A value. So we need to get the value of W from these two parameters. Now cross sectional area A equals to W into D. So area A equals to W into D. So from this, W is area by D. Area 2.5 into 10 power minus 3 by D is 500 micrometers. We know 1 micrometer is 10 power minus 4 centimeters. I am writing that 10 power minus 4 centimeters. Okay, just we simplify this. So by simplification, this is gone. It is 10 power minus 1 here. This 10 power minus 1 and this one. Okay, now this is 2.5. It is 20 times 1 by 20. That is the value of W. Okay, I am keeping that one as usual. Now substitute these values in VH. Therefore, VH is BZ means B, it is a 10 power minus 4 into Ix 1 milliamp 10 power minus 3 by rho V 1.6 into 10 power minus 3 into W 1 by 20, 0.05. 1 by 20 is 0.05. Okay, just simplify this. So now you get, finally it is volts. So 10 power minus, okay, 10 power minus 3 here and 10 power minus 3. So this is 20 here. Okay, now 20 by 1.6. So you can take 200, it is a 16. 4 fours, 4 50s. Okay, now 4 ones, 4 22 2.5. Okay, now it is finally 22.5 into 10 power minus 4 volts, or 2.25 millivolts. That is the Hall voltage. Just whatever the values they given, I collected that values. Okay, so the different thing what I done here is just I calculated the W value from the values of D and area, and rho V value N into Q just I applied. Okay, so only those things I applied, and after that remaining part is a substitution and simplification, not more than in that. Okay, now I am moving to next problem. A silicon specimen has a resistivity of 300 kilo ohm to centimeter. A specimen of silicon has a resistivity of 300 ohm to centimeter. So silicon it has a resistivity, it is 1 by conductivity of 300 kilo ohm to centimeter. 300 kilo ohm to centimeter. So I am writing it is 3 into 10 power 5 ohm to centimeter. Fine. And magnetic flux B is 0.1 Weber per meter square, and D is equals to W equals to 6 mm. D is equals to W equal to 6 mm. Okay. Measure the Hall voltage, and currents are 60 millivolt and 10 microamperes. Measured value of Hall voltage is 60 millivolts and current is 10 microamperes. So you need to measure the mobility mu p, whole mobility you need to measure. Okay. Now first from this, rho v is 1 by sigma, we know that. They given it as 3 into 10 power 5. Okay. From this, I am going to writing the equation for this. So equation for conductivity is 1 by P into Q into mu P. P into Q into mu P. Okay. Just keep it. Next, they given Hall voltage to you. From Hall voltage, what is possible to measure? Which parameter is possible to measure? We check it. Hall voltage, we know that B into I by rho V into W. They given I value also to you. I value they given it as 10 microamps, and Hall voltage also they given. Hall voltage is 60 millivolts. So in this they given this one, B value they given 0.1 Weber per meter square. I value they given. Okay, and W also they given. From this we are going to getting rho V, volume charge density. This rho V is nothing but a P into Q. So now I am writing this one is 1 by rho V into mu P. So whatever the mu p you want, that mu p is 1 by rho v into resistivity over. So mu p is 1 by rho v into resistivity what you have. Okay, now I am going to getting that rho v from this. So VH value they given it as 60 millivolts, 60 millivolts. Therefore VH 60 milli 10 power minus 3 volts equals to B value is 0.1 Weber per meter square. Per meter square, 1 meter is 10 square centimeters. Now it is 10 power 4. I is 10 microamps. 10 into micro 10 power minus 6 by, you have rho v. So rho v as usual into W. W they given 6 millimeters. 6 milli 10 power minus 3 meter. In terms of centimeters it is 10 square. Okay, just simplify this. This is a 10 power minus 3. It is a 10 power minus 3. Now it is 10 power minus 6. Gets cancelled. It is 10 and it is the square gets cancelled. Okay, now from this rho v is 0.1 it is. Now I am taking this is a 10 square. 10 square, okay, 1 by 6 into this 60 into 10 square into 10 power 4, 10 power 6. Okay, so now it is 1 by 36 into 10 power minus 7. Okay, now take this value, substitute here. Therefore mu p is equals to 1 by rho v is this much, 1 by 36 into 10 power minus 7. Okay, 10 power minus 7, this is the value we get, into resistivity. They given 300 kilo ohms, 300 kilo, 10 power 3 or 3 into 10 power 5, no problem. So this is 2 plus 3, 5. It is 10 square, it is 100 now here. Okay, now it is 12 times. So 1200 centimeter square per volt to second. This is the value of mobility. Just they are asking the mobility value. Okay, whatever the basic equations we derived from drift phenomena, conductivity, resistivity, I used that, and after that whatever the Hall voltage equation we have, I used that Hall voltage equation. Okay, after that I substituted values into that. That's it. Okay, so now we move to next problem. See here, a material has Hall coefficient of 2.5 into 10 power minus 10 centimeter cube per coulomb and its resistivity of 2 into 10 power minus 5 ohm to centimeter. Calculate the carrier concentration and mobility. See, Hall coefficient is 0.25 into 10 power minus 10 centimeter cube per coulomb, and we know Hall coefficient is nothing but a 1 by n into q. Let us, I am assuming n type semiconductor, because here they did not specify which type of material it is. That's why I am taking n type. Now from this, n equals to 1 by take this one this side. 0.25 into 10 power minus 10 into Q. 1.6 into 10 power minus 19. That is the n value, which is 10 power minus 10 it is, and it is 10 power minus 9. So we can write it as 1 by 4. This one in this, okay, 0.4 times. So it is 1 by 0.4. So take it as 10 by 4. Okay, it is 2.25. 2.25 into 10 power 9. This is the carrier concentration per centimeter cube. Okay, 2.25 into 10 power 9. Okay, this is the carrier concentration. Next, we need to measure mobility. They given resistivity to you. So just before we use that same problem, resistivity is 1 by conductivity, and we assume this is a n-type semiconductor. That's why conductivity is n into q into mu. So which is given as 2 into 10 power minus 5. Okay, now just substitute values. From this one can write mobility is 1 by n into q into 2 into 10 power minus 5. So which is 1 by n value. Just before we calculated 2 into 2.5 into 10 power 9 into q, 1.6 into 10 power minus 19. Okay, into 2 into 10 power minus 5. Just to do the simplification. See, this is a 9, it is 10 power minus 19, so it is 10 power minus 10. Here 10 power minus 5. Okay, now 10 power 15 here. Next is a 2.25, it is 1.6 into 2. So 1.6 into 2, 3.2. Okay, now this much by 2.25 into 3.2. That is the mobility. Just simplify this. So units are everything we converted in terms of centimeters. So centimeter square per volt to second. These are the units. Okay. So like this you can solve the problems on this. So next problem. So statement for linked questions 44 to 46. So here we have a 3 successive questions, 44, 45, 46. For these 3 questions, same statement. Now, first statement is a silicon Hall device at T equals to 300 Kelvin has the following geometry. So they given D value, W they given. D is a 10 power minus 3. D is 10 power minus 3 centimeter, and W is 10 power minus 2 centimeter, and L is physical dimensions they given, sir, 10 power minus 1 centimeter. The following parameters are measured: Ix 0.75 milliamps, Vx 15 volts, Vh 0 plus 5.8 volts, Bz 10 power minus 1 Tesla. So the meaning of this one is 10 power minus 1 Weber per meter square. Don't forget that. Okay. Now first question in that one is the Hall device is n-type, p-type, intrinsic, can't determined. See, here given, here VH value is positive. So once VH is positive, from this I am concluding this, it is a p-type semiconductor. It is a p-type semiconductor. It is a p-type semiconductor. Okay, from the value of VH polarity, from the polarity of VH, it is a p-type semiconductor. Now option is A for this. Okay, option is A. Next, we are moving to next problem. See, now this is 45 question number. So same data, no change in the data. D, W, L, Ix, Vx, everything. The majority carrier concentration will be in per centimeter cube. The majority carrier concentration. From previous problem, you confirmed that the Hall device is a p-type semiconductor. Hall device is a p-type semiconductor. Once it is p-type, the majority carrier concentration is p. How much it is? That is our problem. Okay. Now we can measure this one by applying Hall coefficient. So RH can be written as, for p-type, 1 by P into Q. 1 by P into Q. So P is equals to 1 by RH into Q. Okay. So now we need to measure the RH value. But RHP is nothing but a, RH or RHP is nothing but a 1 by rho V. Now I am going back to my Hall voltage equation. Hall voltage equation is Bz into, our standard equation, sir, Ix by rho V into W. Here whatever the RH or RHP you are expecting, it is nothing but a 1 by rho V. Now in place of 1 by rho V, I am going to writing this RH or RHP. Therefore VH is 1 by rho V is RHP because it is p-type semiconductor into Bz into Ix by W. From this, RHP is equal to VH into W by Bz into Ix. Bz into Ix. Now I am going to substituting the values. Therefore RH is RHP, p-type semiconductor. VH they given 5.8 millivolts. 5.8 into milli 10 power minus 3 into W width they given 10 power minus 2 by Bz 10 power minus 1 Tesla. So this is, I need to convert this one in terms of centimeters. So 10 power minus 1 Weber per meter square. Now it is, so it is a 10 square whole square, that is 10 power 4 centimeter square. Okay, now it is 10 power minus 5 Weber per centimeter square. That is the B value. Now 10 power minus 5 Bz into Ix 0.75 milliamps, 0.75 milliamps, milli 10 power minus 3, 10 power minus 3. Now simplifying this, so it is 10 power minus 5. By combining this, it became 10 power minus 5. So it is take this one here, it is 5800 5800 by 0.75. That is the RHP value. Now I am going to simplifying that. So 5800 divided by 0.75. It is 7733.3. That is RHP. Okay, centimeter cube per coulomb. Centimeter cube per coulomb. Next. Now I am taking that value, substituting here, because my intention is to get the value of P. Okay, carrier concentration P. Therefore, so RHP is nothing but a 1 by P into Q. From this, P equals to 1 by RHP into Q. So therefore, P is 1 by RHP is 7733.33 into 1.6 into 10 power minus 19. So that is into 1.6. So 7733.33 into 1.6. Yeah, that is 12373. 1 divided by 12373. It is 8.08 into 10 power minus 5 into this one is 10 power plus 19. Therefore, whole concentration is 8.08 into, so 10 power minus 5, 10 power 19, it is 10 power 14 per centimeter cube. That is the whole concentration. Yeah, so that is the whole concentration. Just I use the, see this, in this problem I used this one, I used this one to measure the carrier concentration. Okay, next one is 46. So same data. So what will be the majority carrier mobility? So majority carriers are holes, because it is a, first point is it is a p-type semiconductor. So majority carriers are holes. Already we calculated the hole concentration. Now the mobility of that carriers you need to measure. Okay, mu p. How to get that carrier mobility? See this. See here, Ix is 0.75 milliamperes and Vx is 15 volts. The meaning of that one is Here is your semiconducting bar, and they applied a voltage of 15 volts. They are applying. It results a current of 0.75 milliamperes, and the length of this one is 10 power minus 1 centimeter. Okay, now I am going back. We know drift current density is J drift. We can write it as P into Q into mu P into applied electric field. Applied electric field. And at the same time, J drift is nothing but a current by unit area. Current by unit area. Okay. Just by comparing these two, equating these two, I am going to writing mobility is I by area into whole concentration P into Q. P into Q is nothing but a rho V, and that rho V is 1 by RHP. Rho V is 1 by RHP. I am taking that value. So this is rho V into electric field. Okay, now this electric field on x-axis, what you are applying. From this, the electric field Ex equals to the applied voltage, what you applied in x direction voltage, by separation, distance traveled, 0.1 centimeter, that is L. So it is 15 by 10 power minus 1, that is 150 volt per centimeter. So this is 150 volt per centimeter. Now here I is nothing but a Ix, x direction, and area is W into D. That values are 10 power minus 3 into 10 power minus 2. So 10 power minus 3 centimeters into 10 power minus 2 centimeters. That is 10 power minus 5 centimeter square area. Okay, and at the same time, just before we've written 1 by rho V is RHP. In previous problem, already we calculated RHP value. I am going to take that value. So RHP is 7733.3. So it is 7733.33 centimeter cube per coulomb. Now we know everything. Just take all the data values, substitute in this equation. Therefore, mobility is Ix. They given it as 0.75 milliamps. 0.75 milli 10 power minus 3 by area 10 power minus 5 into rho V. 1 by rho V is RHP. So here I am adding RHP. 1 by rho V. 7733.33 into Ex. Ex is 150. Okay, now I'm going to simplify this. It is 10 power minus 3, it is 10 power minus 5. Now we can write it as 75. Okay, 75 by 150, it is 2. 7733.33 by 2. So that is the your required mobility. So 7733.33 divided by 2, that is a 3866.6 centimeter square per volt to second. That is the mobility. Here just I followed the basic equations what we derived already, and I related one equation to another equation based on given information and required information. That's it. I did not done more than anything. Okay, and thanks for spending your valuable time with me. Once again, I am welcoming you all to Unacademy, India's largest online learning platform. During subscription, don't forget to use my code VRAW10 to get 10% discount, and click on this bell symbol to get the notifications, and join our Telegram group to get the latest updates on our upcoming videos. Okay, and please give your comments on YouTube to strengthen ourselves. Okay, and to provide a quality information to the upcoming students. Okay, please subscribe us. Thank you. Thanks to one and all.